find the resistivity of a given wire by plotting a graph between potential difference and current. We need the apparatus, that is battery eliminator, ammeter, voltmeter, resistor, whose resistance first we have to calculate, connecting wires, rheostat, and a key. EB here, see right now the 0, 0. So it is say first here reading 0 why? So what the options can be, either the source is off, and yes, here source is off. So first let source is on, and now connect this, and here all these are in off mode. Now key is inserted. I need be on this. Now the readings. So first we will note down the reading. First the reading of ammeter. So I am here this side. See, when the ammeter reading is 0.1413, here there is voltage 0.59 volt. So write down that one. Now by changing here the rheostat, see, ammeter reading is 0.15, voltmeter reading is 0.66 volt. Again, ammeter reading is 0.1 ampere, then the voltmeter reading is 0.73 volt. See, again the reading of ammeter is 0.18, voltmeter reading is 0.77. Ammeter reading is 0.20, voltmeter reading is 0.88. Since we have to plot the graph, so we have to take more readings. .23, then voltmeter reading is 1.01. 0.28 ampere, then the voltmeter reading is there. See the fluctuation, because as the current passes the wire, here the heat generated, and the resistance depends on temperature also. So that is the fluctuation you are noticing. Now 0.31, then here 1.33. So hope the sufficient reading here. Now if we first plot the graph, then see I have taken the reading and plotted the graph. That is V versus I graph. So if we plot the V versus I graph, we will find a straight line. And the slope of this line, if we take the current along x-axis and voltage along y-axis, we will find a linear graph. Then we have to find its slope, and that slope will be voltage versus here along the y-axis. So slope will be del V by del I, that is the tan theta. Then the resistance is calculated del V by here del I and the value substituted. So whatever reading you have taken, plot the graph, and then the resistance can be calculated. And if we find the average resistance of all the reading, then we can see the variation, that is error. But here our purpose is to find the resistivity of the wire, given wire, by plotting graph. So here resistance is calculated first. Now resistivity is, what is resistivity? That is resistance per unit length, or resistance ohm meter. That is the resistivity. The length of the wire here we have taken 50 centimeter, and we know the formula R equal to rho L by A. So rho equal to RA by L. Now our purpose is to find the area of this wire. For this we need a screw gauge, and that experiment you have done in class 11. So once again I am reminding you, that is simply, so here let me share you some readings. Okay, fine. See, that will be shared with you. So we are knowing what will be the observation, that is the main scale reading, circular scale reading, and the diameter. So we know what is the pitch. Asutosh, what is
Sir,
pitch of this? हाँ बोलिए,
scale division.
क्या बेटा?
Scale division.
Who can say? Any other? Ipshita, what is pitch? Distance traveled, linear distance traveled in one rotation. Yeah, see, now it is. So if we rotate it one rotation, what is the linear distance traveled? Pitch of screw gauge 1 mm, or in some screw gauge that is half mm. So that may be calibrated on the body of the screw gauge. Like here, see, it is 25 into 1 mm. So this 1 mm is pitch. If here it is the half mm, or if not mentioned, then the linear distance traveled in one rotation, that is pitch. So pitch is to be calculated, and its pitch is 1 mm. Then the least count. Least count is pitch by number of circular scale division. So its pitch is 1 mm, and the circular scale division is 100 division. So 1 mm by 100, so that will be 0.01 mm, its least count. Then if there may be the zero error, may not be zero error. If there's, and we know the types of zero error, that is positive or negative. If zero of the circular scale, let me use the magnifying glass. You see here the zero of the circular reference line, here on the main scale reference line, and the zero, if the both jaw touching it, then if the zero of the circular and reference line are coinciding, then no error. If the zero of the circular scale is behind the reference line, then it is the positive error. If the zero of the circular scale is ahead the reference line, then it is the negative error. and accordingly we do the correction. So if the error is positive, correction is plus, number of division between the 0 and the reference line which coinciding with the circular scale into list count, and if it is negative then minus. So here the reading taken by me, and that I will share with you in the Google Classroom. Here note down what's the resistance is and the length of the given wire. Here we have already told you that is the 50 centimeter. So diameter first calculated, and diameter is 1.54 mm. So in centimeter it is 0.154 centimeter. So radius will be diameter by 2, that is 0.072 centimeter. It is the radius of the wire. Now if radius of the wire is known, then area can be calculated by using formula pi r square. And length, here it is taken 50 centimeter. So resistivity will be Ra by L. R is, that is 4.54 ohm. Area will be 3.14 into 0.072 square, by length is 50 centimeter. In that way we will find the resistivity of this wire is 1.47 into 10 to the power minus 3 ohm centimeter. And in that way, our this experiment is completed.